Okay, so let's have a look at question A from question 2 in the test. So here they ask us to complete the Simulink block diagram of this circuit and only use gain, summation and integral blocks. So let's get started. So the first thing we need to do is identify integrations, and this is the simplest way to do it. So here we can identify that component there, that's the integral of the current, there is the current, and there is the derivative of the current. So what I can do immediately is I can drop an integration and another integration. Remember, integrals can be depicted in the Laplace domain by 1 over s. And what we can do now is say that if that is the current, then this on this side is the integral of the current, and this side is the derivative of the current. So I can take the derivative and integrate it, and I get the current, and I integrate the current to get the integral of the current. So now, if I have a look at that output equation, what that output equation does is it just takes this and it multiplies it with 1 over c, like that, and there we have our output. Okay. So now we're almost done. The only question is, what is that? And that first equation actually, this equation actually gives us that. If we rewrite this first equation in this form, saying that the derivative of the current is equal to the input voltage minus R times I minus 1 over c integral of the current, and we divide that by L. So there we've got the equation that describes this signal here. Okay. So clearly it's a summation, and then after the summation it's division. So let's just do that. So let's just draw a summation mark. The input is a positive. So there's a positive line. The current needs to be multiplied by R, like that. And that gets fed back with a minus. And then we also got the minus of the signal here, minus like that. And the last part is the division of by 1 over L. Okay, like that. Okay, and there we go. That is the block diagram to simulate this circuit here. And what's great is it's without the need to derive the entire transfer function, and yes, without actually the need of doing any hard maths. The trick is to identify the integrations.